So how do we produce one of the most important molecules in our body, ATP? Well, the answer is ATP synthase. Given by its name, ATP synthase is an enzyme responsible for the synthesis of ATP. Shown right here, I've drawn a diagram of the mitochondria and its structure. So we have the outer membrane, the inner membrane, and between that is the intermembrane space. Inside of the inner membrane lies the matrix, and on the inner membrane lies our ATP synthase, which is between phospholipids. In the intermembrane space, there is a high concentration of H plus ions, which want to go from a high concentration to a low concentration. So they want to move from the intermembrane space to the matrix, like so. Above, I have a blown up picture of the inner membrane. So our H plus ions at a high concentration want to just move through, right, to the low concentration, just like so. But they can't. They can't just move through the phospholipids just like that. That's where ATP synthase comes into play, because ATP synthase has access channels which allow H plus ions to go from a high concentration to a low concentration. So they move through just like so. And that movement causes our C ring to also rotate, which we're turning electrochemical energy in terms of the gradient, high concentration, low concentration, into mechanical energy by moving our C ring, which is right here. Right? So if our C ring moves, our gamma subunit, which is also called the axle, also moves because they're connected. Right? This movement opens and closes our alpha and beta subunits, which are right here. So when the alpha and beta subunits are open, it allows ADP and phosphate to enter and to bind to the catalytic sites located there. Once they're binded there, the movement of the axle closes the alpha and beta subunits, which in turn forcefully reacts ADP and phosphate, creating ATP, which comes out right here. So this cycle is nonstop, and it creates ATP from an electrochemical gradient, electrochemical energy into mechanical energy, back into chemical energy in the form of the high energy bonds of ATP, which we can see right here as we obey the laws of thermodynamics, as energy is transferred 3 times during this process, from electrochemical energy to mechanical energy to chemical energy.